Alright, the next topic in our Unit 8 rational functions is solving them. So here, you can use the operations that we just did, add, subtract, multiply, and divide, to solve rational equations. You need to simplify both sides so that each equation, each side of the equation, each expression, is just a single rational expression. That means you want one fraction on the left and one fraction on the right. Once you simplify it to one fraction, then you can cross multiply to solve. So another way to say cross multiply, because you're not going to see that all the time, because what does cross mean? I mean, some people get their x confused with straight across. So instead of cross multiplying, we're going to say multiply denominators, because that's basically what you're doing when you cross multiply. Okay, so if we look at the first one here, example number 1, zoom in. So in geometry, you cross multiply these two, and you set those, when you had a proportion, you set those cross products equal to each other. We're going to kind of do the same thing, but we're going to think of it a little differently. So just like we did in common denominators, we want to say, what does this denominator have that this one needs? Well, it only has this thing, so it needs this one. So to this side, we're going to multiply this denominator. 3x minus 5. Whatever we do to the bottom, we have to do to the top. 3x minus 5. So then on this side over here, you ask yourself, what does this denominator have that this one needs? It has x minus 2. Whatever we do to the bottom, we have to do to the top. So the thing about equations is once the denominator is the same, you can actually just ignore it, because they basically cancel each other out. And you just solve this part. So we're going to distribute here. So notice when you cross multiply, you do the exact same thing. The cross multiplying that you did in geometry, when you did 5 times this, that's what we're going to do up here. 5 times this stuff. And then the other way, 20 times this is what we're going to do over here. So again, you end up with the same thing, but it's going to help us in other problems if we think about it as multiplying by denominators. Okay, so this denominator goes away and this denominator goes away. So if we distribute the left side, we get 20x minus 40 equals, distribute the right side, 15x minus 25. So again, once the denominators are the same, you can ignore them and solve the numerators. Okay, now just solve for x. Get numbers to one side. I'll move this to this side. So 5x over here. Move everything to the other side. Plus 40. Plus 40. And that's 15. 5x equals 15 divided by 5. X is 3. So we are going to have to be careful with this answer. It might be extraneous, and I'll talk about what that means in the other one. Back when we were simplifying, we said the excluded values, x cannot be this, x cannot be that. This is what we're going to need them. Because if you look at our original denominator, so for this stuff, if my answer is 2 here, my excluded value, x cannot be 2. Because if I had a 2 as the answer, I would have 0 here, and that doesn't work. And then for this one over here, 3x minus 5 equals 0. When is that going to be 0? When x is 5/3. So x cannot be 5/3 as well. So we're going to still need to think about this, because if the answer happens to be one of these numbers, then it's not an answer. It's extraneous, which means when we plug it back in, it's not going to work. Okay, so we are going to need some of these for some later problems. Okay, so if we look at example number 2, again, still finding that common denominator. Let's say real quick what x cannot be. So for this denominator, it cannot be positive 1. And for this denominator, it cannot be negative 7. So if our answer ends up being those, then we have to throw them out. Okay, it becomes an extraneous solution. Alright, so this denominator, we want to multiply this side by x plus 7, x plus 7. This denominator, x minus 1, we need to multiply this side by x minus 1, x minus 1. So here the denominators are the same. They're both x plus 7's, x minus 1's. So I can ignore them. I can only look at the numerators. Okay, so for this one, in order for me to multiply it out, I'm going to have to FOIL. So here, x squared minus 4x plus 7x minus 28. So x squared plus 3x minus 28 is what that one factors into. If we distribute the right side, we get 10x and a minus 10. So equals. So notice here we have an x squared, and it's not going to cancel out because when I combine like terms, it still leaves an x squared. So when you have an x squared here, you got to ask yourself, how do I solve a quadratic? Well, there's a lot of methods now. One more easier than the other. So here we could use quadratic formula. We could complete the square. We could factor. Or we could graph it and see where the x-intercepts are at. So put it over here, graph, and get the x-intercepts. So these are the way we know how to solve. Any of these ways requires it to be equal to 0. So I need to get these to the other side and make it equal 0. So here I'm going to subtract 10x from the 3x. So that's negative 7x here. And then I'm going to add 10 to the negative 28 to get negative 18. And then the x squared just comes down. So this is the quadratic that we're trying to solve. So again, we could plug it into the quadratic formula, a, b, c. We could complete the square, divide by 2 and square. We could graph it, figure out the x-intercepts. But factoring is probably the easiest. So for factoring, you're either going to use GCF, difference of squares, basic, or AC. So here, since it's a trinomial with a equal to 1, we're going to use basic. So this is not your answer. That's just what I'm trying to solve. So x, factors of negative 18, that add to 7. So 18, there's 1 and 18, 2, 9, 3, and 6. So 2 and 9 is the one that I want, with the bigger one taking the negative sign. So this is our factored form. When we solve it, it actually wants the solutions. So that means we set each factor equal to 0 and solve. So here, if we add 9 to both sides, we get x equals 9. Here, if we subtract 2 from both sides, we got x equals negative 2. So these are the answers if they're not this. So 9 is not an excluded value, negative 2 is not an excluded value, so both of them are okay. If either of these ends up being this answer, we have to throw it out. Because they cannot be these, because when we plug it back in, we divide by 0, and we can't divide by 0. Alright, so we have one more where we have to cross multiply or multiply by denominators. here, we're going to take this denominator and multiply by this side, x plus 5, x plus 5. And then we're going to take the other denominator, x plus 2, and multiply this side by x plus 2. Again, you can only do this right away if there's one fraction on this side and one fraction on this side. If you have stuff on the outside, there's actually an extra step you have to do. Okay, so now that the denominator is the same, ignore this and ignore this. This one we're going to have to FOIL out. So x squared minus 3x plus 2x minus 6. So we get x squared minus x minus 6 equals, this side we just have to distribute the x. So here, x squared and plus 5, or plus 5x. So if you look at it this time, yes, we have x squared, so we have a quadratic, but notice I have an x squared on this side. So when I combine my like terms, these actually cancel each other out. So I'm just left with this linear equation. So I can get my x's to one side and my numbers to the other. So add x to 5x, so negative 6 equals 6x. Divide by 6, x equals negative 1. So let's just double check that it's not an excluded value. So here my original denominators were plus 5 and plus 2. So that means my two excluded values are not equal to negative 5 and negative 2. So these are the ones that cannot be, and this is not it. So this answer is okay. We are going to come across some answers where we do get that, as we get one of these numbers as the answer, and we have to throw it away. Okay, so alright, so in the notes, the next few are word problems. I'm actually going to skip the word problems, and those are going to be on the next part. I want to get all the equations done today. So this whole page is word problems, this page is word problems. So I'm going to skip to number 9 and do these problems because they're regular solving. And then the next part will go into the word problems. Okay, so notice here, we don't have just one fraction and one fraction. So we can't just multiply by opposite denominators. So when solving, it's useful to get rid of all the fractions at one time, and then you can solve like normal. So to get rid of all the fractions, you multiply everything by the least common multiple between them. So the least common denominator between all of them. And this is called clearing the denominator. So here, actually I'm going to split this up. I'll clear the denominator on this side, and then I'm going to come over here and show you how to do it by finding common denominators. I don't care how you do it, as long as you can solve. Okay, so over here, if you look at all three denominators, what's the least common multiple between all of them? So 3 would be 3, 6, 9, 12, 15, 18. 4 would be 4, 8, 12, 16, 20. 6 is 6, 12, 18, 24. So the least common one between all of them, least common multiple, is 12. So that means I multiply everything by 12 over 1. So I'm multiplying everything by the least common multiple. So when I do that, here we're going to do top, top, bottom, bottom, and get 12x over 3, which is going to reduce, and we'll do that in a second. And then I multiply this one to get 36 over 4. And you multiply the last one to get 12 over 6. So if I reduce all of these, 12 over 3 reduces to 4x, 36 over 4 reduces to 9, and 12 over 6 reduces to 2. So notice here, all the fractions go away. So when you multiply by the least common multiple, you clear the denominator because there is no fractions. And now you solve for x. So minus 9, 4x equals negative 7, divide by 4. X is negative 7/4. So that's solving it by clearing the denominator. You can also solve it by making all the denominators the same, which is what we just did on the other one, and then combining your like terms in the numerators. So here, if I wanted to make each denominator 12, so you're still going to have to deal with 12, because that's the least common between all of them, I'd have to multiply this one by 4 to make it 12. I'd have to multiply this one by 3 to make it 12. And I'd have to multiply this one by 2 to make it 12. Alright, so I get 12, 12, 12. So this one ends up being 4x over 12 plus 9 over 12 equals 2 over 12. So notice here, all the denominators are the same. So when all the denominators are the same, just like I did before, I can ignore them and just deal with the numerator. 4x plus 9 equals 2, which is exactly the same thing I got here. 4x plus 9 equals 2. So you get the same answer. It's just a matter of which way you like best. Do you like clearing the denominator and multiplying it out? Or do you like multiplying each fraction to make the common denominator and then just look at the numerators? I'll probably go back and forth. You can choose which one you do. Okay, so if we look at example number 10, now we're getting in, this really wasn't irrational. These are just regular fractions. Over here, I'm getting into actual rationals because they have x's in the denominator. So for this one, I'll clear the denominator. So clear the denominator. For this one, I'll multiply each fraction and find a common denominator, and then just look at the numerators. Okay, so over here, what's the least common multiple between all of them? Well, that's going to be a 3 and an x. So I'm going to multiply everything by 3x over 1. Okay, so when I multiply the first fraction by 3x, I get 24x over x, because just 1 times x is just x. So when you clear the denominator, really you're just multiplying the numerator. The denominator stays the same. Alright, multiply by the second one, 3x times 11, it's 33x over 3 equals, multiply negative 14 by 3. Negative 14 times 3 is negative 42 over x. I'm sorry, negative 42x over x. So now I reduce. So notice here these both have an x. So that's just 24. Plus these reduces to 11x. This reduces to negative 42. So I cleared the denominator. Now I just solve for x. So subtract 24 from 42, negative 42. And I get negative 66 divided by negative 11. X is 6. Okay, so here, this is multiplying by the least common multiple. If you were going to make all the fractions the same, you would say, what does this denominator have that this one needs? Well, it has a 3, so I'd multiply them by 3. What does this denominator have that this one needs? It needs a x, so I would multiply it by x. I get the same answer. It doesn't matter which way you do it. Okay, so now we're over here. So I'm going to put parentheses around this one. So this time I am going to ask, what does this one have that this one needs? But before we do that, looking at the 2 and the 10, what's the least common multiple between 2 and 10? That's going to be 10. So I actually want to multiply by 10 and not 2, because that's not going to be enough. So here, what does this denominator need that these have? Well, this one has. It has a 10. So I need to multiply this by 10. So I'm going to end up with 20 over 10 times x plus 3. There. This one, what does this one need that these have? This one actually needs a couple things. To make 10, you need to multiply it by 5. Multiply by 5. And it also needs this factor x plus 3. So x plus 3, x plus 3. So on the top and on the bottom. It needs both. So I'm going to end up here with 15 over x plus 3. Or sorry, 15 times x plus 3 over 10 times x plus 3. You're trying to make them all the same. Equals, well, this one already has the 10, but it needs the x plus 3 that this one has. So I need to multiply this one by x plus 3, x plus 3. So I get 19 over x plus 3 over 10, or 19 times x plus 3 over 10 times x plus 3. So notice all the denominators have 10 times x plus 3. So they're all the same. So I can just look at the numerators. So here I'm going to get 20 plus, distribute the 15, I get 15x plus 45 equals, distribute the 19, 19x plus 57. And again, linear, you just combine your like terms and solve for x. So over here I can actually combine the 20 and the 45 before I start moving it. So that's 65. So 15x plus 65 equals 19x plus 57. So getting my x's to one side, minus 15x from the 19, and that's 4x. Subtracting the 57 to the other side, minus 57. So 65 minus 57 is 8. And then just divide by 4. X is 2. So again, I don't care which method you use. Sometimes one is easier than the other. I think it's easier to do this method when you have a binomial. When there's more than one thing in the denominator, it's easier to use common denominators. When you only have a singleton in the bottom, it's easier to use least common multiple. But in the end, it's up to you. Alright, so got a few more of those. And then we'll move on to the applications. Or go back and do those applications. Alright, so notice here for example number 11, first of all, this plus 2, I'm going to make it a fraction. So I'm going to change this one to 2 over 1. And I'm actually going to do the common denominator one here, and not the clearing, not the least common multiple. Okay, so in this denominator I have x plus 3. In this denominator I have 1. This denominator I actually want a factor. So basic, negative 12 to get negative 1 is 3 and 4, with the bigger one being the negative. So positive 3, negative 4. So now this is my denominator. So here I'm going to make all of the denominators the same. So for this one, I'm going to ask myself, what does this denominator have that this one needs? Well, it has a plus 3. It needs the minus 4. So I need to multiply this one by x minus 4. Whatever I do to the bottom, I have to do to the top as well. So I'm going to have to FOIL this part out. Right here. Okay? And then for the 2 right here, you ask yourself, what does this both denominators have that this one needs? Well, this one only has a 1. Which means it really doesn't have anything. So it's going to need both of them. So to the 2, I'm going to have to multiply by x plus 3 and x minus 4. X plus 3 and x minus 4. So right now, this is what it looks like. First fraction, x minus 4 times 3x minus 5 over x minus 4. X plus 3, don't cancel them out because then you defeated the purpose of multiplying them. Equals 2 x plus 3 x minus 4 over x plus 3 x minus 4. And then this one didn't need anything because it already has both of them. So this one's just going to stay 8 over x plus 3 x minus 4. So notice all the denominators are the same. Minus 4, minus 4, minus 4, plus 3, plus 3, plus 3. So I can actually just ignore these. Well, before I completely ignore them, what can x not be? Well, for all of them, since they're all the same, x cannot be negative 3. Because then that would be 0, that would be 0. And it cannot be 4, because then this part would be 0. Okay, so those are the excluded values, so now I can just get rid of it. Okay, so we're going to multiply this out and then solve. So here we get 3x squared minus 5x minus 12x plus 20. So I'm going to have 3x squared minus, how many x's is that going to be? 17x plus 20. And then on the other side, I need to do the same thing. So here, I'm going to FOIL this out first and then distribute. I'm going to get a x squared minus 4x. Actually, it's this answer up here. So I'm going to get a minus 4x and a plus 3, which is a minus x, and then a minus 12. But I have to multiply it by that 2 in the front. So here I'm going to multiply this by 2. And then I have that plus 8 on the outside. So I'm going to end up with 2x squared minus 2x minus 24. And then the plus 8 at the end. Okay, so if we look at the x squareds this time, they're not going to completely cancel out, but they will simplify. So I got to figure out how I'm going to solve this quadratic. First of all, I need to get one side equal to 0. So if I subtract 2x squared here from this, I end up with just an x squared. Here I have a 2x, so I'm going to add it to the 17, negative 17, and get negative 15x. And then for this number, this right here is negative 16. So I'm going to add 16 to both sides, add 16 here, and get positive 36. So now that it's equal to 0, I'm going to solve this quadratic using basic. Okay, so 36. What are the factors of 36? 1 and 36, 2 and 18, 3 and 12. So I know they both have to be negative. So which ones, when I add them together, do I get 15? So here I want the 3 and the 12. Okay, so setting each one of these equal to 0, add 3, x equals 3, add 12, x equals 12. So these are the answers that could work as long as they don't equal this. So 3 is not the same thing as negative 3, so this one's good. 12 is not one of these. So both of these end up being answers to this rational expression. Okay, so notice that's this thing says solving a rational expression with two solutions. So both the answers that we get are going to work out. But for number 12, this one's going to have extraneous solutions, which means one or both of the answers that we get might not work because they're excluded values. So looking at number 12, again we have to factor first. Well, let's say with the excluded values. Yeah, let's factor. So looking at the first fraction, if we factor this denominator, here it's a minus, so a difference, perfect square, perfect square. So differences of squares factors into plus minus. And then you just take the square root. So square root of 16 is 4 and 4. So this is this denominator. So before we do anything, let's say what x cannot be. X cannot be, for this one and this one, it can't be negative 4. And then for this one, minus 4 and minus 4, it can't be positive 4. So these are the two answers in the end that are not going to work. Alright, so let's see what we got. We ask ourselves, what does this denominator need that these have? It needs a x minus 4. So multiply this by x minus 4. What does this fraction need that these have? Well, it needs the plus 4. So multiply this one by x plus 4. X plus 4. So now that they're all the same, I'm actually just going to, from here, cancel them out. So this goes away, and this goes away. I'm just looking at the numerators. Because it's a minus sign, I'm going to change it to adding by making the numerator negative. So I get 6x squared. Go ahead and distribute the negative 3x minus 3x squared plus 12x equals, distribute the 4 over here, 4x plus 16. So here, the x squareds are not going to cancel again, so I'm going to get all of them to one side, including these, so that it's equal to 0. So combining these together, I get 3x squared. Moving my x's to one side, so subtract 4x from the 12. And I get 8x. And then moving my 16, there's no constant over here, so the minus 16 just stays. Okay, so now I still have a quadratic. Check for GCF. Is there a GCF? Doesn't look like one. So, not difference of squares, not basic. I'm going to have to use AC for this one because of that number in the front. So AC, we multiply 3 and negative 16. 3 times negative 16 is negative 48. And we want to factor negative 48 to get 8. So 48 is 1 and 48, 2 and 24, 3 and 16, 4 and 12, 5 doesn't work, 6 and 8. So these all give me 24. To make negative, I need one positive, one negative, and I want the bigger ones to be positive. So then these are the negative ones. So which one's going to give me the 8 that I need? The negative 4 and positive 12. So this 8 is going to become negative 4x and 12x. But the 3x squared comes down, and the minus 16 comes down. So now we factor by grouping. So take these two and divide out an x, and we're left with 3x minus 4. take these two, and it looks like they can both be divided by 4, positive 4. So then I'm left with 3x minus 4 again. So the thing that they have in common is the 3x minus 4. So factor that out, and then I'm left with x plus 4 as my factor. So I'm going to go through these factoring ones pretty quickly. If you still have questions with the factoring ones, then you need to go practice AC method more. I'm not going to re-explain how to do these slowly in detail. I'm just going to assume you know how to do it. And if you have questions, you can come ask about how to factor these. Okay, so now we solve them, setting them equal to 0. So here, this one's the easier one to solve. X is just negative 4 here. For this one, we have to add 4 and then divide. So 4 equals 3x divided by 3. X is 4/3. So it looks like both of these are the answer. But notice, I have a negative 4 here, but at the beginning I said it couldn't be that. So this is a contradiction. So the negative 4 is actually an extraneous answer, because it doesn't work. This is the only answer to the problem, is the 4 over 3. Okay, so that's what it means to solve when it has an extraneous solution. That the answers that you get may or may not work. You have to check it at the beginning. Alright, so the last two are very similar. Still factoring, and then checking our answers. So looking at 13. Doesn't look like the first one's factorable because it's linear. The second one we need to factor, but this one is already linear. So looking at the middle one, factors of 15 that add to 8 are 3 and 5. Usually you'll have something the same. Very rarely will I give you 3 different factors to multiply by, because then that gets into cubics and that's just too much work. Most of the time they're just quadratics. Okay, so what does this fraction need that these have? It needs an x plus 3. X plus 3. This one already has the x plus 3, x plus 5. But what does this one need? This one needs the plus 5 and the plus 5. So notice here they all now have x plus 3, x plus 5. Before we start canceling it out, what can x not be? For the plus 3's, it cannot be negative 3, because then I get 0. For the plus 5's, it cannot be negative 5, because then I get 0. Alright, so now I can just cancel it out. Goes away, goes away, goes away. And I just distribute the numerator. So for the first one, I get 2x squared plus 6x. For the second one, I really don't have to multiply by anything, but the minus sign that's here, make sure you distribute it to everyone. So here, that's going to be negative x squared. Here, that's going to change it to a positive x, and then a positive 10. So don't forget the negative one, the subtracting ones, don't forget to distribute that negative. Alright, and then the last one, 3x and a plus 15. So once again, I have some x squareds that are not going to cancel out, so I need to get everything to one side. So let me combine my like terms over here first, and then I'll get everything. So I can combine the 2x and the negative x to get just x squared. 6x plus x gives me 7x, and then the plus 10. And then 3x plus 15 on this side. Okay, so in order for me to solve a quadratic, I got to make it equal to 0. So minus 3x from the 7 to get 4x here, minus the 15 from the 10 to get negative 5 here. And the x squared just comes down. So now we have a quadratic with an a value of 1. So there's not a value in front, not an a value, it means I can use basic. So what are the factors of negative